All right, guys, that was a bit embarrassing. So after some time, I already forgot how to set my live streaming setup, and I messed around with some cables. Couldn't manage to do it, but yeah, finally we are live. Hello, everyone. I really missed you these weeks, but today we are back. We are live with a new build. Yeah, let me know in the chat if everything is okay, if you can hear me. And yeah, today we have an interesting topic. We will continue the signal clone, and specifically today we're gonna focus on the end-to-end encryption aspect of the Signal application. When we started Signal clone, that was in my head, that was the main idea of this application, that it should be secure and specifically end-to-end security encryption, in order for messages not to be able to be read even by the application provider or by internet providers. Yeah, this is the difference between Signal and other chat applications. So we have managed to build 5 videos with different features in this application, like messages, photo and audio messages, text messages, smiles and emojis, and a lot of other features. But yeah, today is the time to take this build to the next level and implement the security with end-to-end encryption. So shortly, let me figure out with my devices here. All right. Yeah, so in this video, we're going to talk about, first of all, what is end-to-end encryption. Then we're going to speak about how does it work from a high-level perspective. And finally, we're going to implement end-to-end encryption in our Signal clone. And we're going to do the public and private key generation, then saving these keys where they are intended to be saved. For example, not exposing the private key and so on. Also, we're gonna implement the encryption and decryption of messages that are sent and the messages that are received on the user profile or device. All right, so yeah, if you're new on this channel, hi, my name is Vadim, and I'm glad to see you here, and I'm thankful that you joined today's live stream. I'm a full-stack developer for over 7 years, and nowadays I'm decided to share my knowledge and my experience that I have with you guys here on YouTube. So if you enjoy what I'm doing here with Not Just Development, please smash the like button and subscribe to the channel. And yeah, I'll be very grateful for that. Also, you can follow me on social medias, on Twitter and Instagram at Vadim notjust.dev. I post there a little bit more often, so some behind the scenes you can find there. All right, so without further ado, let's roll the intro and then we're gonna get started. And we are back. So, all right, so first of all, let me greet everyone who has joined our chat here. So I'm using the same mouse for 2 PCs, and it's pretty tough to switch from one to another. So hi everyone, where are you joining us from today? Hello, Steve, Siva, Surya, hello guys. I didn't think you will continue with video 6. I also didn't plan to continue with video 6 because yeah, these weeks I went back to my home country, and it was 3 weeks, and now I came back and I decided to start with a new build, which I can't wait to start. But I thought that it's very important to implement this end-to-end encryption, and it's also something new for me and very interesting how to do this stuff in React Native, and that's why I decided to take one more day and implement this this important feature in our application. Okay, so push notifications. Yeah, guys, a lot of people are asking about push notifications. However, this feature is a bit more advanced, and I'm thinking to dedicate a separate video to it. And yeah, I didn't plan the date when I will work on it because I'm pretty busy with working on the course. But I'm definitely gonna do a separate video on push notifications. So yeah. Please share all previous videos. You can find all the previous videos, by the way, in the link in the description below. All right, okay. Okay, so guys, let's speak about encryption. And before getting into the specifics of end-to-end encryption, I want to talk a little bit from a high-level perspective about encryption in general. So there are two types of encryption: symmetric encryption and asymmetric encryption. When it comes to symmetric encryption, the key that you use to encrypt data and the key that you use to decrypt data is the same key. So here in this diagram, you see that you have a plain text, you use a secret key to encrypt the data, and after that, on the other end, you use the same secret key to decrypt the data. This is fine for some scenarios and some use cases. However, this in our chatting messaging, this does not solve a lot of problems for us, because this secret key, as you can see, is used on both ends, encrypting and decrypting, and you would have to share it. And if anyone else will discover the secret key, they will be able to decrypt your messages. So this has also some drawbacks. On the other hand, the asymmetric encryption uses two separate keys to encrypt and to decrypt the message. So to encrypt the message, we are using a public key. A public key can be shared anywhere on the internet. It is meant to be public. However, to decrypt the text that was encrypted, you need the private key, where here it's called the secret key. And this secret key is the key that you should not share. It should be kept privately on someone's device. So, yeah, what else I can say here about this? Yeah, the most important part here is that the public key can be shared. Using the public key, we encrypt data. The private key should not be shared anywhere, should be kept private. And with the private key, we decrypt the data. So two separate keys are involved here. And you might have encountered this asymmetric type of encryption if you are using GitHub or GitLab. So there you most probably have set an SSH key where you generated a key pair, a public and a private key on your computer. Then you took the public key and gave it to GitHub. Now every time you make a connection, your data is encrypted with a public key and then decrypted on your end with a private key, and only you can decrypt this data. So that's why, yeah, this way it improves security because only the person who owns the private key or who knows the private key can decrypt it. Okay. All right, so this is about symmetric and asymmetric encryption. So as you can see here, we need two keys. So let's have a look a little bit about the process of generating these keys and how and where we can save it. So here I'm speaking in the context of our application, of our messaging application. So for example, the use case is the next one. So a user enters the application, he creates an account. After in the process of creating an account, the mobile application, the phone, will generate a key pair. A key pair consists of a private key here on the top and a public key here on the bottom. Now, what should we do with these keys? So first of all, as I said, private key should not be shared anywhere. So we should keep, oh my God, what's going on here? So we should keep our private keys private and secure on the device storage. So we take this private key and we save it to the device storage, on the user's device. We do not share it anywhere with the backend, with a database, and so on. It should be kept privately. All right. The next one is the public key. This public key can and should be shared with other users that you want to exchange information with. So the public key we save to database. In our case, that's going to be AWS Amplify, and we save it there together with the user account. Okay, if you have any questions on this slide, let me know, and I'm going to try to explain. But yeah, it's pretty straightforward. We generate two keys. The private key we save to the device storage. The public key we save it in database so that other users can query and can get our public key. Okay, so sending a message. When you send a message, you want to encrypt this message. So imagine that the user A sends a message to user B. So user A will type on his keyboard the message in a plain text message, like in plain English or any other language. Now, in order to encrypt that message, we need to know the public key of the receiver. So if user A sends a message to user B, then we need to know the public key of user B, because we want only user B to be able to decrypt this message. And because in the previous step we have saved every user's public key in the database, from the user A side, we can query the public key of the user B, the user that we are chatting with. We get it from our database in AWS Amplify, and then using this public key of user B, we encrypt the message. We encrypt this message, and we get an encrypted message. This encrypted message is already not in plain text, it's not English, it's encoded, encrypted, and this message can be saved in our database. And now even we as administrator or AWS or anyone who is looking at the data in the database, they will not make any sense of the data because everything there we keep encrypted. Okay, this is one step of a process. This is one part of a process of sending the message and encrypting. Now, on the other side, here from user A, we send the message to user B. Now let's see how user B will receive a message and how he will decrypt it. So on the user B side, he will query all his messages from AWS Amplify. Then AWS Amplify will return him a list of encrypted messages, or let's say one encrypted message. Now, how we will decrypt it? First of all, we need to read the private key of our user, which we saved on the user device. So to read the private key, we are reading the key from the user's device, which is kept safely there. Now, having the encrypted message and the private key of a user, we can decrypt the message, and only we can decrypt the message because only we know the private key. Anyone else having this encrypted message will not be able to decrypt it. Now, this process will decrypt it. We have a decrypted message in plain English, so it's back to normal text. Then this message can be displayed on the screen. So, yeah, this is from a high level the whole process of generating private and public key pairs, then encrypting the messages that you intend to send and decrypting them. One note here that I want to say is because each message is intended for one user, because we encrypt with that user's public key, the use case when there are a lot of people in the group, but I'm going to explain a bit later. For example, if there are 5 users in a group, you should save the same message 5 times in the database. Basically, you take the plain text message and encrypt it with each user's public key and save it separately, because you want only that specific user to be able to decrypt it. Other ways would be to somehow generate a public-private key for a specific group, but in that case, you'd have to share the private key among group users. And sharing private keys is not good in terms of security. So that's why we will have to think how to design our database in order to meet this requirement that every message should be saved multiple times, encrypted for every user in a group. Yeah, basically that's what I wanted to say. Bro, how long is this video? So yeah, we just started. I just covered a little bit of theory about encryption, decryption, symmetric, asymmetric encryption. And now we're gonna get our hands dirty and try to implement these features in React Native in our Signal clone. So get ready, get yourself some coffee. I didn't have time to get myself some coffee because I've been preparing this live stream from 7 in the morning. And yeah, let's hope it's gonna go well. So yeah, I wanted to say that this is the first time when I actually implement encryption. So it's gonna be a fun process. Let's see how it goes by the end. All right, let me first of all check some comments. So we are going to implement encryption alone. Yes, I want to focus this video only on encryption, but we are gonna have a lot of details here. Like to implement a very basic encryption, something that I was playing around and testing, that's gonna be not that hard, but to design and change our database structure to encrypt, decrypt, and save everything, that's gonna be a bit more difficult, but we're gonna do it. So, okay. Unfortunately, it's nighttime in India. We'll be unable to follow the live. We'll watch it again when I get free. Yeah, the video is gonna be available on the channel, so you can watch it afterwards. What's the time there? It's free here. All right, guys, so we have a lot of things to do today, so let's get started. First of all, I would like to switch my mouse to this PC and to run our application to see where are we with it. So here I have our application from the previous video. So if you haven't followed that, I recommend following the previous video, or you can clone the part 5 the repository and move to the part 5 branch, and that branch will contain the code that we are using today. So yeah, here on the left we have our application, and it contains a list of groups. Why it has... One second, guys. Come on, settings, accessibility. Where is it? General. I want to change to light mode because the application doesn't show good. Display. Come on, where is it? Privacy, passwords, no. Oh, come on. Yeah, I cannot do it. Or is it device? Okay, never mind. So where is the application? Go back to the application. Yeah, the issue is with the header. In a dark mode, it displays, you cannot see the title of a page, but it's there. So as well with creating new groups here. But what we're gonna focus today is, let's open some chat rooms. Yeah, this is a chat room. And here we can send messages. Hello. And we can see that it has been delivered. It has not been read yet. All right, so now our next step is to take this message and to encrypt it and save it encrypted in our database. Because yeah, like, why do we need to do that? It's because it's to provide like privacy, because with this approach, let me try to show what you can do. So let me open AWS console. Let's sign in. And here, let's open AWS Amplify page and the signal clone. So from here, I'm gonna press Edit Backend to open the admin UI. So in the admin UI here, we as the administrator of the application, we are able to see all the, where is it? Not chat rooms, but let's say messages. We are able to see all the messages and see what users are chatting about. An application that respects the privacy of the users should make sure that these messages are encrypted, and they, as the application provider, they should not be able to see what the users are talking about. This is sensitive data, and yeah, that's why we need to encrypt it. All right, so to do that, we are gonna use a couple of libraries. So if let me open the first one that we will need. It's called tweet knuckle, and here it is. Or even it's for GS. Yeah, this is a library which has been ported to JavaScript. It's based on this tweet NACL. I'm not sure if I pronounce the name correctly, but as far as I research, this is a very well-known cryptographic library. And specifically, this library also had an audit, so you can be sure that it works securely and does what it say. So using this tweet knuckle library, or tweet NACI, I don't know, can someone confirm me how it is called? Using this library, we can first of all generate public and private keys. Then using these public and private keys, we are also able to to encrypt and decrypt information. Okay, cannot find it here in the documentation, but we are gonna get there. So yeah, this is the one. So using this secret box, we can encrypt a message using the public key, decrypt it using our private key, and do all these use cases that I have shown you previously. So let's start by installing this library. Second. So, yeah. Come on, where is it? Yeah, npm install tweet knuckle. Let's go in our project and let's open our terminal. Let's open a new terminal here and let's install the library using npm install tweet knuckle. So while it is installing, let's wait a couple of seconds. And from where is it? Yeah, here. From the examples, where is it? Examples. Let's try to do to generate a key pair. So let's open this wiki with examples, and let's start with generating a simple random bytes, like a random array of bytes. So I'm gonna copy this random bytes and this import. This is what we will need. So in our application, let's open our app.tsx, or yeah, let's do our work here in app.tsx, and after that we're gonna see where it's better to move it. So at the top here, let's import, what do we have to import? Secret box and random bytes. Secret box random bytes from tweet knuckle, and let's just console log the some random bytes. The cryptography depends a lot on random numbers. So for example, a math.random is not a perfect function from cryptography. That's why it's very specific, like which library is behind the random generator. So let's just console log here random bytes. Okay, if I save it, secret box, we see an error, no PRNG. Okay, so this error, I spent a lot of time understanding what's the issue about, but basically what it means is there is no native library that will handle the random generation of numbers. So in this case, in our Expo environment, there is no default one. So in browsers, there are default ones, and because this tweet knuckle works with JS, it works in browsers, and in browsers it can detect this PRNG automatically. But in our case, it's a different environment. It's Expo, it's on mobiles, so we need a way to manually set this PRNG that will help us generate a random array of bytes, basically random numbers. To do that, to generate random numbers in Expo, there is a library called Expo Random. Yes, Expo Random. And with Expo Random, we can use functions like get random bytes and sending the byte count, how many random bytes it should generate. So we can use this one to provide random values to our cryptography library. So let's first of all install Expo Random. And after it's will be installed. Let's go back to our documentation of TweetKnuckle and see here somewhere a way to set PRNG. Okay, I'm gonna. So here you can see if a platform you're targeting doesn't implement secure random number generator, but you somehow have a cryptographically strong source of entropy, which is not math.random, then we can implement this PRNG manually ourselves. So this cryptographically strong source of entropy, for it we are going to use expo.random, expo random. So let's copy this function and let's define it here in our application. So before doing random bytes, we need to do, I'm going to import set PRNG from TweetKnuckle and remove it from here. So set PRNG, a function that receives two parameters, and inside the function body we should copy n random bytes in the x. X is an array of bytes, n is a number. So we need to, if n is 10, we need to copy 10 random bytes into x. Okay, so how we're gonna do that? We are going to use our expo.random and specifically get random bytes. So let's import get random bytes from, oh my god, where am I? From expo random like this, get random bytes. Okay, so first of all, let's generate a list of bytes, like an array of bytes. So const random bytes equal to get random bytes, the function that we just imported. And here it expects the number of bytes. So the number of bytes is this n that we will receive, like this, random. And now we should copy the first n bytes from this array to the x array. So simply let's do a for loop from 0 until n, because we need to copy n bytes, I++. X of I is equal to the random bytes dot I. And that's it. That's everything that we have to do. Now our console log random bytes should have, if everything works, should have output some random bytes. Let's have a look at our page here. Let's clear everything and let's try to reload. Let's select the iPhone from the left panel, and here there are some issues with two children, but that's not related to our stuff. I saw there an array here, an array with random bytes. And this means that the library that we're going to use next is working properly on our system, in our application, using expo.random as a random generator. By the way, guys, if you, because we have worked on this signal clone, like we started more than a month ago, your API key might have expired. So here is a side note. If your API key expired, Because it expired for me and I had some issues with the key. And I think even now, no, now I don't have it. So to fix that issue, if your key is expired, go to Amplify here, backend, API, parameters.json, and here, if I can remember what was the name of that parameter, Amplify API generate API key. Where is it? Making generate. No, it's not here. It's the first link. And you need to add the API key expiration epoch to 0. So here, API key expiration epoch. You add it to -1. Now from the terminal you do amplify push. What this will do, this will delete your API key because it is set to expired. And when you're going back here after you did the push, you delete this line and you do push again, and this will generate a new key and everything will be working again. So this is a little bit of sidetrack if you're having these issues. But now let's continue with our library. Okay. Okay, all right. So let's have a look at our secret box. An example using symmetrical crypto, a single key for encryption and decryption. No, that's not what we need. We do not need symmetrical crypto. We need asymmetric. So you can scroll down a bit in the examples. And here is the example for asymmetrical encryption. Okay, all right. So first of all, let's add a folder called, not here, let's do it in the root, called utils, and let's add a file called crypto.js. And we're gonna keep all the function methods for our crypto here. The first function that we will need to move here is from the app.tsx is the set prng. So let's copy this function from the set prng and let's move it to the crypto. So let's do it as this. Let's delete the, we will transform it into an arrow function using the arrow here. And we're gonna do export const prng equal to this one. Okay, in our app.tsx, let's do import prng from utils crypto. So set prng to prng. Back random bytes. Can find get random bytes. Yeah, because get random bytes should be copied from here and imported here. Save, and now it works back as we expected. Okay. So the next step is to do the encryption, or no. Before encryption, we need to manage the key pairs. We need to manage the keys for our user. What will be the steps to do that? So I'm thinking that first of all, let's try to copy this example in our application and make sure that everything is working from this example, and to make sure that, yeah, like we have this encrypt and decrypt functions, and then we're gonna think how to put it together with our backend. So let's copy our encrypt and decrypt functions from here. Encrypt and decrypt. Let's copy them and let's put them in our crypto.js. Okay, starting from the encrypt. What do we have here? So basically we are not using TypeScript here, so we can delete the types for our variables. So I'm gonna delete it from here, delete any, and delete the type of a key. If I save, we are in the same line: secret or shared key, JSON that we want to encrypt, and the key. Okay, behind the scenes, it takes the keys, it decodes our, it encodes our message from string to be of type unsigned int, and then that message from bytes, it encrypts it using the secret key. Okay, so there are a couple of things going on around here. We can go into more details about them a bit later, but now let's try to see if it will run. And the same with the decrypt. So here, let's delete the types of our parameters, because we are not using TypeScript at the moment. And yeah. Now, where do we get these new nonce? We're getting it from where? Yeah, it's a function. Yeah, we will need the two function, new nonce and generate key pair, which is gonna be here on the top. All right, generate key pair, box key pair. Okay. I think we will not need this one. Yeah, this one, the question mark from the key, it says that also can be used only in TypeScript. So, yeah, new nonce, we have it here, decode UTF. They are importing decode UTF and base64 from Tweetnacle util, and this is a separate library. This is a separate library that we can install, and it provides some utility functions that are not specifically related to cryptography, but they are more about encoding into byte array, decoding from base 64, encoding to base 64, and so on. So as you can see here in this notice, instead of this package, the creator recommends using the stablelib packages, which are intending for the same functionality. So I try to use the util function, this library, and it gives you an error because again, there are some missing dependencies on in the environment of Expo and React Native. However, the stablelib and stablelib base 64, they are working fine in our environment. So let's grab them and let's install them. So let's just grab the name of them and let's do npm install stablelib, this one, and stablelib base 64. We need these two. One is to convert from and to UTF-8, and one is from N2 base 64. So let's start importing this from stablelib UTF, and one we will have from stablelib base 64. So here we have a function decode UTF. So for the UTF, we can destructure decode, and let's rename it because we're gonna have the same decode here. So let's rename it to decode UTF-8. Make sure to name it the same because it is used in the code as decode UTF-8. And also encode as encode UTF-8. The same for the base 64. So let's take the decode from there as decode base 64 and encode as encode base 64. Let's save. And now we have the decode, and we also have decode, encode, decode, and encode below. All right, so let's now take the rest of them. Where is it? Random. Of the example. Here is the example, right? And after the decrypt function, we have here a demonstration of encrypting and decrypting. So let's take this object and let's go to our app.tsx. So I'm gonna remove these random bytes, but I'm gonna do okay, object hello generate key pair. We're gonna generate key pair. Let's go into the crypto and do const export const generate key pair is gonna be where is it? Box. Generate key pair. If I'm not mistaken, that's how it is done here. Generate key pair, box, key pair. Okay, it's key pair. Key pair. No. Key pair. Like this? Yep. So let's import the generate key pair from there. And what else? We will need box from tweetNuckle here. Encrypt from crypto and decrypt from our crypto. The functions that we just created in our crypto here, encrypt and decrypt. Okay, so we then have an object, a JSON object. It has a key hello and the value world. Then we generate a key pair for user A and a key pair for user B. Okay, so I'm gonna move it a bit around, you know, but no, let's do it like this. Now let's think that user A wants to send the message to the user B. What the user A will do, this is not from here. Let's do it like this. So what the user A will do, it will create a shared key based on the user B public key that he will query from the database, which can be public, and the user A, his secret key. Then with this shared key, he can encrypt the object that it wants to send. It encrypts it there. On the other side, user B will create a shared key using the sender public key and his secret key. And then he will decrypt it using this shared key. And when we console log, we should see that the object, the object and decrypted should be the same. So let's have a look. Okay, undefined is not, we have an error. Undefined is not an object evaluating Expo random box key pair. Key pair here. Expo box key pair. Expo random. Key pair. Let me check the documentation for generating the key pair. Knuckle box key pair. Generate a new random key pair for box and returns it as an object. Set PRNG. Let's try to reload the application. Come on. Reload. Hello guys, everyone who is just joining. We today, shortly, we are implementing asynchronous end-to-end encryption in a chat application. So right now, generate key pair. It's somewhere here. Generate, export, generate box. I think I know why. We need to do this set PRNG probably here on the top. So set PRNG is gonna come from Expo random. And it crashed completely, but we will be able to try again. Try again. What's going on? Let's try to Did it stop? Yeah, I think it stopped. It crashed. So I'm gonna restart the server here. Let's just restart it and hope that the issue will go away. And let's run on simulator. So set PRNG is not a function where in crypto. Let's do it directly here. Set PR. It's not from Expo random, of course. It's from, where is it? And box as well is not from here. I was thinking about import box and this from tweet knuckle. can find variable set prng app.tsx. Okay, yeah, we need to remove set prng from here. This one. And now can find variable random bytes. Random bytes. Oh, random bytes. What? It's in crypto in new nonce crypto.js. Random byte. Yeah. Wait a second. I think I missed something. Random bytes. Yeah, not randomize, but get random bytes. Unexpected type object string as this. So this is happening, and I know for why. This is for decoding and encoding the message from string to the UTF, like the unsigned integer array. So the only thing that we have to do is to replace from decode UTF-8 to encode, because it has been messed up in these libraries. So encode here UTF, and encode UTF. As you can see here, it expects a string, and that's what we are giving, JSON stringify, and it will return a uint8 array. That's what we expect. And where we are using it again, here, encode UTF. Encode UTF will expect a string, but we are giving an array of bytes, so that's why we need to replace with decode UTF. Save. And now it should work. Let's have a look in our here. Let's scroll through some logs, or let's do it again. Reload. I saw it somewhere. I saw something. So the initial message was object hello world. This is the encrypted message, which looks quite random, and the decrypted message is hello world. And as you saw here, we encrypted the message with the public key of user B, but we decrypted it with the private key of user B. So we simulated encrypting and decrypting on two sides. All right, so this, with this being said, we know that we can encrypt and decrypt and generate keys for in our application. Now our goal is to integrate these functions of encryption and decryption in our messaging part, and also generating the key whenever the user signs up, saving it there, and then using it properly. Okay, so before that, I really need a coffee. So 1 minute and I'm gonna be back, and we are gonna continue implementing our encryption specifically for our messages. You know what? No, I'm gonna go and make myself a coffee whenever I will wait for our API to update. All right, chill. So let's first of all then think about what data changes we will need in order to accomplish this. So if we look at our, where is it? Keynote here, I'm gonna go through some of the diagrams here and look for the parts where I'm referencing AWS Amplify. So here we need to save a public key of a user to database. For that reason, our user, the data structure for our user should contain a new field called public key. Okay, then yeah, the message should also do something. All right. All right, okay. So let's go in our admin UI. So if you don't know how to do that, open your AWS console. From here, go to AWS Amplify. And let's open Signal Clone, edit backend. And in the admin UI here, we're gonna do some changes to our data structure. Let's go to our data here. Okay, 1 second. Yeah. Now you should see it better. Let's go in our data here in the left side corner. And first of all, edit the user table and add a field here, public key. The public key, we will keep it as a string. Yeah, let's keep it as a string. And actually it should be required because if a user does not have a public key, nobody can send messages to him. But yeah, let's keep it as not required in this case because we already have some user in our application and not all of them have the public key. So let's, this is one thing, public key for the user. Now, the next change. As I said, now that we encrypt each message for specific users, we say that this message should be read only by the specific user B. Then our message should be adjusted to point to the user to which it is intended, so that we know that, okay, this is the message for me, I should try to decrypt it, and if it's not a message for me, I don't have to decrypt it, and I don't have to display it in the application. So we will, in a group of 5 people, we will have to save 5 messages with the same content, but encrypted with different keys for 5 different users. So I'm gonna add a new relationship, and one message to one user, one message to many users. No, it's one message to one user, right? So if I save, did it add? What did I do there? No. User ID is relation source. Okay, add relationship, user, one message. A relationship name is for user. For which user this message is intended. For user. Messages. Okay, let's try it like this. for user. I hope that it will contain this for user. We'll be able to save it. Yeah, let's try. Let's try to go on top and do save and deploy. And this will deploy our new changes. Please make videos using JavaScript. That's what I'm doing. I'm using JavaScript. So until we wait for our backend to deploy, which is going to take 1 to 2 minutes, I'm going to go ahead and grab myself some coffee. But you don't leave anywhere. We're going to continue with our end-to-end encryption. All right, so it's still deployment in progress. Can you please tell me that how can I add radio features in Spotify app as I'm making my major project for my undergraduate? I don't know, like you should find some radio APIs. I don't know how it works, specifically with radio. Like, I don't know, you can integrate it with some APIs, but that's not radio, that's some Spotify API or the SoundCloud API. I guess they have a public API. And you can integrate it with that. And I think for an undergraduate project, that's going to be very good. Okay, come on. Yeah, it's almost done. Did you show how to implement number of unread messages, and if so, in which video? No, we didn't implement that feature. We implemented other interesting features. I'm gonna give you some ideas of how you can implement it. So in our data, message status sent, delivered, read. So you're gonna do a query with a very specific filter. A filter that will filter the messages to be part of that chat room that you are looking for example, which has a status of unread. And that query that has a status of sent. And that query will show you it should be sent or delivered. Everything except read. That query will return you all the messages that have not been read yet, and you can pop that bubble. The issue there is going to be that it's going to take into consideration as well your messages that you are sending. So you can filter as well based on the user ID to be different than your ID. So you'll have a couple of conditions there. One, that the chat room should be the chat room that you are looking for. The user ID should be different than yours. And the status should be different than read. And that will return the necessary ones. Okay, so deployment successful. Click the next for the next step. So let's grab the amplify pool command and let's go back in our project and let's run amplify pool. This will bring all the changes for our data structure in the database. We'll bring them here locally in our project. I need coffee. Will the chatting functionality actually work? The chatting functionality works at the moment as well. So everything that you saw here, I can open it on my device. And this, where is it? I cannot open it now on my device, but yeah, this chatting, everything works as expected, and it's also real time. Also displays the status of a message, if it's sent, delivered, or read, and so on. So right now our successful generated models. Okay, successfully generated models. And now what should we do? Amplify. Let me see something. User item. Okay, so the first step will be to in our user table, where is it? We need to save the public key for the user and to save a private key in on our device storage. So where will we do it? So the thing how it works right now is that our logging logic, like sign up logic, is handled by the automatic authenticator, which is coming from Amplify. So we cannot actually hook in the let's say the moment when the user signs up, creates his account, because it's handled here by the authenticator. The authenticator will create the user in our authentication service, which is Cognito. And then in the second video, I think, of our tutorial, we have implemented that, where is it? Amplify backend function, that Lambda function that will save our user. Whenever a new user is signed up, it will save it in our DynamoDB, basically in our database. The thing is that here as well we cannot add the private key because this function is executed in the cloud. The whole point of generating the public and private key is to happen on your device so that the private key will not travel through the internet. It's gonna stay there privately. So it cannot happen here. Then where should it happen? That's the interesting part. Let me think where we can add it. Should we add just a simple button that will set or update the private key? Yeah, let's do it that way, because when we will add that button, we will be able to update and generate a new key if you think that your key has been compromised. So having that button is not that bad. Like, preferably it should happen automatically. And because of some of the reasons that I told you right now of how things are happening at the moment, it's going to be more difficult to implement generating the key automatically, like without any user input. On the other hand, let's let's define a screen for some settings. So I'm gonna do what? New screen, new file, settings.tsx, and React Native functional export settings. Here are our settings. What I'm gonna bring to the settings, I'm gonna bring this ugly logout button that we needed only to test how logout works. And where is it even placed? It's in the screen, chat room, no, home screen. Somewhere here should be this logout. Yeah, let's grab it from here and bring it to the settings screen. We will need to import pressable, and we will add another button like update key pair on press logout, which is coming from where? Come on, logout. Okay, it's here. Settings and data store clear and authentication as well. Okay, perfect. So now we need to add a way to navigate to the settings, to our settings. So in our navigation, chat room header, should I add it there? I can add it there for a moment. You know what I'm gonna do? I'm gonna delete this color scheme. And now, yeah, because that was messing with my color scheme. Or I can do it. Where is it? Color scheme. No, I'm just gonna. Let's do it like light. Perfect. Okay, so in the chatroom header, I want to add one more. No, not in the chatroom header. In the index home header here, home header, I'm gonna add another pressable. I'm gonna copy it from here. No. I'm gonna, yeah, and I'm gonna put it instead of a camera because we don't need that camera. The name will be, I don't know, settings. Do you have something like this? Yes, it has settings. And on press, it's gonna go to the settings screen. But because we don't yet have a settings screen, let's define it here. So stack.screen, name settings, and component equal settings and that's it. And I'm gonna bring it here. No, not settings from here. We need to import settings screen from screens settings. Let's replace the name here. And if I press on the navigate settings, right? Settings, yes, now it works. It goes to a new page with the settings. Okay, perfect. So in the settings, app.tsx, no, settings. Let's add another pressable. Very bad styles there. Why is it red? I don't know. White. Okay, so the text for this pressable, the first one will be update key pair. So whenever we press on update key pair, let's add the function update key pair. Async. Okay, so what should happen? First of all, generate private and public key. Then save private key to Async Storage and save public key to user model in data store. These are the steps that we need to take. Okay. To generate private public key, we already saw that in our app.tsx. We implemented it, and here is pair A and pair B. So let's take one of here, go to our settings page, generate public key. I'm gonna destructure right away and generate public key is gonna come from crypto utils here. Well, it's not here, it's from one above, utils crypto generate key. So it will return a key pair, and the key pair, where is it? Come on, it should have a private and a secret, right? Un momento. Here, public key. So let's right away destructure them. Public key and secret key. Okay, generate key pair. Save private key to async storage. Our secret key is of type, unsigned integer array, so basically an array of bytes. And whenever we save it to async storage, let's see if we already have Expo Async Storage. Let's install Async Storage, and this is going to be the library that will help us save some data on the device storage. That's what we need for our private key. So let's do Expo install Async Storage. But before that, let's just do console log public key and secret key. And now let's have a look at the logs. Let's go to the settings page and press on the update key pair. Okay, yeah, because, okay. That happened because the function was not assigned to the on-press event for this button. So let's update it here and let's log in once again. Yeah, it's here. So let's go here, update key pair, and that should have. Yeah, here is one of the keys, which is the first one is public and the second one is private. Both of them are array of bytes. Okay, so was that installed? I'm gonna go ahead and do a git commit, just because I'm afraid not to mess up something and not having a point of going back. Encryption work in progress. Okay. So let's, where is the documentation here of Async Storage? Import Async Storage is, yeah, is set item and get item. Okay. All right. So save private key to Async Storage. First of all, let's define a string that will represent the key, not to hard code it always. So public key, public key. So const, no, not const, await async storage dot set item. The key that we want to, the name of the variable that we want to write, basically don't confuse the key here with our private key or secret key, because this is just a name of a variable, how we want to write and how we want to receive it back. And the value is going to be our secret key here, dot to string. Okay, sync storage set item, public key, secret key to string. You know, I'm thinking if these things are better to happen in our crypto file, because we have it there. Settings. Okay, never mind. Save private key to async storage, and then the next one is save public key to the user model in our data store. Okay, first of all, we need to get the user from our data store. So user data equal. Let's first of all receive the user that is authenticated. So auth.current authenticated user. Then based on the ID of the authenticated user, we're gonna get the database user is equal await data store dot query. We are gonna query the user model We don't have it. Let's try to import it. Import from source models, and where we have user as user model. Let's do it like this. So where are we? User model with the ID of user data dot attributes dot sub. This is the ID of a user taking from the authentication. So let's do console log db user first of all to see if we find correctly the user. So right now it should, whenever I press on this button, it should search and find the user, the authenticated user. So nothing happens. Nothing happens. Why nothing happens? Settings. Wait, set item. Console log. Secret key was saved. Console log db user. Let's try to reload because it doesn't seem to have been. Oh no, yeah, I see here user. Everything is fine actually. It just takes some time, right? Yeah, secret key was saved, user, and here it is. So yeah, the user is here, public key is still null, but we can fix that and we can say await data store dot update, or how is the update function? Update, no? Save. And we're gonna save a copy. In what screen did we have updating? Components. Chat room item. Copy. No, it's not here. Let me find in folder. Copy of. I remember it's copy of. Yeah. So data store save the message model, copy of the message itself, updated. Okay, got it. So we want to update the user model. And which user model? The DB user. And here, oh no, user model dot copy of the database user, and updated user will contain private key, public key, I mean, is equal to public key dot to string. So argument of type user undefined is not assignable. Oh, we need to check if we didn't find the database user, we return, but before returning we want to alert dot alert user not found. I don't know. So let's do update key pair, and in advance let's do alert dot alert successfully updated the key pair. How to write successfully. Like this. Okay, update key pair, successfully updated the key pair. Okay, so let's see what it saved in our, where is it? Amplify admin UI. Let's go to the content. You're saying that the code is not visible. Yeah, now I zoomed in a bit. Oh, come on. So for the users, let's see if, yes, look, this user, which is me, has a new public key in form of a string of bytes. Okay, good. And whenever I do update key pair, let me remember the last 88 is the last one. Update key pair. Okay. Let's reload. It was 88, now it's 105. So that basically means that we can rotate our keys. Something to keep in mind is that whenever we will update the key, you will not be able to decode past messages, because we are overriding your private key here. Where is it? Your Async Storage. Not public key, but private key. Just some naming convention, but yeah, let's not confuse anyone. So in our Async Storage, we are saving the private key, not the public key. Okay, save private key to Async Storage. All right, so the first step is done. The next step is gonna be sending the messages. So what's happening here? Reload. So whenever I send a message to some user, I should first of all encrypt it with his public key and then send it. Okay, let's think how we're gonna do that. That is going to happen in our message input component, message input. Oh, it's a long component, I would say. Okay, let's see what we have here. It has images, it has message to reply. Look, the only thing that we're gonna do is we are gonna encrypt the text message. Let's start with the text message. So our text message should be a state variable with message. Yeah, it's this one. Okay, so when we press on the send button, which is the last one, where so on press, let's see what on press function is doing. On press checks if the image, it sends the image, sound. Let's focus on only the send message function. Let's encrypt only this one when it's a textual message and not when there is an image or something like that, just to simplify our code. So send message is the function that I saw it here, send message. Okay. Wait, the data store content message. Yeah. This message should be encrypted. This message should be encrypted. Okay. So, let's think. Okay. I'm thinking what's gonna be the best way to do it. So first of all, let's write down some steps that we need to take. Get the public key of the other user, in case it's only one. No, actually it's get all the users of this chat room. Then for each user, encrypt the content with his public key and save it as a new message. Okay. For each user, encrypt the content with his public key and save it as a new message. All right, that makes sense. So first step is get all the users of this chat room. So const users equal await data store dot query. We're gonna query chat. Okay, chat room users. Have we done anything like this? We need to query chat room users, but we need chat room user, which was imported from models. And we need to filter chat room user, only the one chat room user dot chat room ID is equal to chat room ID. So this is getting all the users. Let's do console log users. And I'm gonna comment out everything else, or I'm gonna do return here because I want to skip execution down below just to test it out. If I do return, my VS Code automatically deletes it, so I'm gonna comment it out. Okay, let's open our page here and let's try to send here. So what do we have? We have two chat room users. One should be me, and one should be Elon Musk. User Vadim, this is me, and it has a public key. And the other one is Elon Musk, but he doesn't have a public key yet. So how we are gonna do it? You know what? Probably the best way will be to simulate the communication between me on the phone and me on that one, just so that both of us can have this public and private key, and we will simulate it. Let's try to see if it will run on my phone. Oh, it's downloading very slow. Let me try to switch things around here. Reload. Reload, come on. So, one more thing, that from this list, we only need the users. We don't need anything else. So from that list, I'm gonna do also map chatroom user to chatroom user, get only the user from there without anything else. And now if I do like this, if I send, I see an array of 2 users. First one and second one. And the thing is that we also should save a message for ourselves. We need to encrypt it with our public key so that the logic of decryption will work on our side as well. So in a chat room of 2 people, every message should be duplicated. Once encrypted with one user's private public key and once with our public key. And let's opening the project. Come on. Try again, back home. No, go back. This one. Okay, this one is loading a bit faster. Now, for each user, encrypt the content with his public key and save it as a new message. Okay, so what will happen? For each users, that means a mapping. So for each, let's say, for each user, we want to what? Send message to user. This function is going to send to all the users, but this one will send to a specific user. So it will receive a user here. And it will, I will copy some of the things from here, send message. Send message to user. User. All right, not So for each user, we are gonna send message to user, but because this is an async function, we will need to wait the execution of sending a message to all users. So for that, I'm gonna map through this, and this will return an array of promises, which we can do await promise.all, and we're gonna await the execution of sending a message to all users. Update last message and reset fields. I'm gonna think about this in a moment, how we're gonna update them. So the good thing is that now the application runs on my device, so I can log in from another account here. Come on, where is the... Let me log in there. Okay, I am here. Reload. And it's a chat with support, so might be this one. Last seen online a month ago, and you'll see that come on, work. I have an error. Null is not an object. Evaluating user image URI. That's in the chat room item components. Chat room item. At 57. User is possible null. So I'm gonna do it like this. And now, null is not an object. Evaluating user name as well here. I don't know. Okay, now it works. And support notjust.dev. Is it this one? Hello? Oh, message input here. Send message to user. So let me uncomment this one because I want to see the messages appearing there. So this is the user that is sending the message. So it's not changing, so we can take it out of there here. Await current authenticated user. And I'm gonna send it here. Send message to user. This one from user ID. No, the from user ID is gonna be there, but here is user attributes.sub. So besides the user here, I'm gonna receive from user ID, which I'm gonna put it as a user ID here. And the message, what else does the message have? Message. Okay, here, user ID, and it has a for user. Why it doesn't have a for user ID? Now I'm thinking that it would have been easier if we just set a for user ID instead of for user. Yeah, because this relationship is only for filtering. So we don't actually need to show for who is this message. We just need to know the ID of that user. So I'm gonna have to update our data here. And for the message, I'm gonna remove this relationship for user. And I'm gonna simply add a for user ID. For user ID? Yes, it's a string. It's an ID actually. So let's now save and deploy. And again, it's gonna take a couple of time to do that. Hello, Fulbright. Hello, Vitor. Yeah, and now it's deploying, so we're gonna have to wait a bit. But the idea is that now from user, but this is for user. So for user ID, we're gonna do user.id, specifying for which user is this. But let's comment it out right now because it will not work. New message. What else? New message. Do we need to do anything with it? Let's reset the fields. Update last message. Update last message. Yeah, let's call this update last message here. Actually, we don't need to call it for all of them, only for one of them. Last message will also be interesting, to be honest. Okay, so we might actually break this functionality of a last message because it also depends on the key of encryption and decryption. So let's comment it out until that, and let's try to do hello. Hello. I cannot send anything. Hola. Undefined is not an object evaluating user attributes sub user attributes with one T. No, user. Oh, is okay. Of user dot attributes dot sub. Okay, now, yeah, it sends 2 times. At the moment it displays 2 times as well, but later on we're going to implement the logic to see if the message is for us, then display it. Otherwise, do not try to display it. Okay, so if I send some messages from... Why they're not appearing here? They're not being saved. Oh, maybe because our backend is in deployment, so let's try not to break it and wait a couple of seconds. But until then, let's think about our next steps. So we have here the user. The user has a public key. Now we need to encrypt using that user's public key. If we look in our app.tsx, to encrypt, we need to build this shared key between the user's public key and our secret key. So let's copy. So shared key is gonna be a key that we compose out of the public key of a user that we want to send the message to, and our secret key. Our secret key. Our secret key. Our secret key we can simply not to fetch it all constantly. We can save it in our state. So const or let's just get it here. So const our secret key, is await async storage dot get item, and we're gonna get item with the same key that we saved it. So here private key. I can do here export const private key in order to make sure that we are using the same string from screens settings, and from there I'm gonna import private key. This is just a string that we are using to access the key in our storage. So if our secret key is null, then we do alert dot alert, you haven't set your key pair yet. That can happen when you open the application, you do not go to the settings, you just go right away to send a message. In that case, you don't have any secret key. So the alert will say you haven't set your key pair yet. The message, go to settings and generate a new key pair. And the buttons will be, title, title, open settings, and I can do on press here, I can automatically redirect him to navigation dot I need an access to this navigation. So import use navigation const navigation equal use navigation, and when we press open settings, navigation, navigate settings, title string is not assigned to alert button object name, or how is it called, or text, or oh come on. Title, text, yes, text. And that's it. Yeah. So in the case of my phone here, and what else? And we should stop the execution, because we don't want to send the message if you don't have a private key. So here, if I write something, you haven't set your key pair yet, go to settings and generate a new key pair. Open settings, navigation, settings here, open settings. Why it's happening? Oh, it's for two users. Open settings. But why private key? No, not private key. Just private key like this, get item. And now it's the same. But why? If I do update key pair, it should set the key pair there. And now whenever I do get private key, yeah, now it works. And if I reload, it should still work. Like, it's written on our device storage, so it should work across different sessions. Right. So now if you send something, yeah, it works. We do not see that one. Can find variable box. Okay, yeah, that's from the next step. Our secret key, user public key, shared key. Okay, let's import box from import. Oh my god, so many imports. Okay. Box from tweet knuckle. So box our secret key. Okay, argument of type string is not assignable to parameter of type uint array. Okay, so the thing is that we read the private key as a string. So if I do console log private key, private our secret key, you will see that it's just as a string. So we need to somehow transform it. I'm gonna name it string here, and we need to parse it and transform it to our secret key from a string. So I'm gonna take the string. How to transform it? Let's first of all look at the structure of this key. Okay, where is it? Come on. Oh, and our backend has finished deployment. So let's have a look at the structure of a key. Where is it? Can't find variable our secret key. Let's comment it out for a moment. And here replace our secret key string. Okay. And now, if I do send, here is the private key, and it's a simple string representation of that array of bytes. So first of all, let's think how we can transform from this string to back to a string of bytes. Maybe there are better ways, but the way I would do it is I would first split the string based on the comma, and this way we get an array of simple strings. Then we transform each individual number to an integer, and from there we transform it to the array of unsigned integer. So let's do that right now. So const our secret key is equal to, first of all, our secret key string dot split. We want to split it based on the comma. Then let's map through each number, each string actually, and transform it to an int, parse int str. Okay, now our secret key should look like an array of here. It's an array of numbers, but we need an array of uint numbers. So wait a second. What is the method to transform this to? Let's try to search it. JavaScript int 8 array. So there is this method from creates a new array from an array-like or iterable object. Okay. So we can put everything here in this function. So we create an array of unsigned integer based on our string. So if I send it again, our private key is of type that we need. And now if I send our secret key here to the share key, it doesn't give me any errors because it's of the expected type. What I want to do is to extract this to a separate function in our crypto library because we're going to use it more. So where is the utils crypto? Export const string to int 8 array equal string, and it returns that one, string. So let's import it here in our message input, string to array, and we will send the and we import it from where? Do we have here utils? Utils. No, we don't. One more import. Import from come on. Utils, no. Utils. Utils, no. Utils, yes. Crypto. Okay. Now it should work back as it was working before. Send. If I look there, I should see the array. No? Unhandled promise rejections. Rejection. String is not a function. String to is undefined. What is undefined? String, this one? Crypto. Export const, this one. What? Alright, I'm already lost. Shared our secret string to, yeah. Why are not working? Reload. Hey Edison, thank you very much for your support. Hi Alexandra, yeah, I ate. I'm alone at home. Oh no. Come on, what's going on here? Run. Why it's not running? What happened there? Let's check the server. Let me stop the server because I'll have to do something. I'm gonna close a couple of things here. And let's do the Amplify pool because we updated, but we did not pull the changes. So I'm gonna do here Amplify pool with my app ID that I copied from Amplify admin UI. And let's wait a couple of minutes. Updated. Now I can uncomment for user ID this one because our message contains already for user ID. And let's run again the project. npm start. Marco, the short answer. Marco asked about Uber clone autocomplete feature and if you need to turn on the billing on your account. So the short answer, yes. In order for the autocomplete from Google to work, you need to enable billing. If you don't enable billing, you don't get any errors, you just don't receive any suggestions. So it's a pretty nasty error, which is hard to debug, but if you know that you have to enable billing there. Okay, so back, here we are, this one, and here, let's try to send something, and if I open here, yeah, we see the key, type error. Okay, so shared key. Shared key. Are you creating this shared key? I don't know. Console log shared key is shared key. And const encrypted message is gonna be await encrypt. Is it await encrypt? Let's open our app.tsx. So encrypted is just encrypt, shared A, and the object. Encrypt, shared A is the shared key, and the object. Let's just send the message. The thing is that we implemented this to work with JSONs. I don't know, I can do it like this, like an object with a message. The message, yeah. And the content will not be the message, but will be the encrypted message. Let's also console log to see what's going on there. Encrypted message. All right, let's see here what's going on. Send. So, user. Public key has, but this user does not have a public key. Support. I haven't sent my public key yet here, so that's why it cannot send private key. Okay, private key. Yeah, I know why. We need one more check for the user public key, the same way as we did here for our secret. So we can do if user dot public key, come on, public key, if user public key, then we're gonna do the same alert. The user haven't set his key pair yet. Go to settings and generate a new key pair. In this case, we cannot do anything because ask just, yeah. Until the user generates the key pair, you cannot securely send him messages. So right now, if I'm gonna try to send here something, the user haven't set his key pair yet. Until the user generates the key pair, you cannot securely send him messages. Okay, let's now from the other side of the screen on my phone here, I'm gonna reload and I'm gonna generate a key pair here. Go to Expo Home. I need to enable tunnel. And after I generate the key pair here, then both users have their key pairs and they can safely communicate between each other. So let's see, where is it? Oh, come on. Loading. And now on my phone, I'm gonna go to the settings, similar to what we have done here, settings, and I'm gonna press on update key pair. But first, it should load. Are you for hire? Now, at the moment, I'm focused full time on YouTube and on the project that I have. So, my app has loaded here, update key pair, successfully updated key pair. Now, from here, let's reload in any case. And go to our support.notjust.dev and try to send him a message. What do we have? We have a list of users. Both of them have a public key. Here is our private key, which is perfect. The private key, again, our private key, and handle promise rejection. Type error, unexpected type object, string, use this. But where? So what we see here, a private key, but shared key. Okay, so again, the public key here in our case is of type string. So I'm gonna have to do the same there. String to yeah, like this. And let's do the same right away here. Okay, shared key. Let's try right now. Because in database, our public keys are of type string, but we need... Okay, I see it. So it saved 2 messages and both of them are encrypted. Encrypted message, shared key. That's perfect. One message is intended for us to see, and another message is intended for the other users. For example, here, if I show you like this, I still see 2 messages. Come on, focus. And yeah, first of all, let's filter the messages that we display only to be the messages that contain for user ID, our user ID. Basically to display only messages intended for us, not for everyone else. And when we will implement that, the past messages will go away because we do not have a for user ID, but the new messages are going to be displayed. So where is that happening? That is happening somewhere in screens, chat room screen. And here, fetch messages, await data store query, message model. Message model where message chatroom ID equal to chatroom ID and for user ID is equal to my ID. But my ID, I can get it with I can do it like this. Of user equal await authentication dot current. Let's import first of all authentication. Current authenticated user and const my ID equal auth attributes dot sub. Now we fetch messages only that has their for user ID equal to our ID. So in this case, as you can see, the message starts with EQ. It's encrypted. We're gonna decrypt it later. But I want just to show you that if I don't have this one, if I don't have this part to filter based on who is it for, I see both of them. One of them ends with U equal, the other one ends with 4 equal. So if I remove, here I see only 4 equal, but on my phone, I see the other message, which is with, come on, doesn't want to focus, but it's the other message. So now we display correctly the message who is it intended for. The only thing is to decrypt it. Give me 1 second and I'm gonna come back and we'll continue with decrypting the message. All right, I'm back. So, what I was saying. Decrypting the message. Let's go in our app.tsx and see how it happens. Okay. This is the ultimate stuff, bro. Thank you. Thank you very much. So to decrypt the message, now we create this shared key, but we create it based on the sender public key and our secret key. Okay. Where we will do it? Let's do it in our components, message component, index. No, message here. So what's happening here? Props. It has some icon, text, message content. Yeah, here, message content. Message content. Okay, this is the stuff that we need to decrypt, the message content. Where is it coming from? Our message is in state, and we get it if message, no. Okay, use effect. Where is the user? Oh my god, there is so many things happening here. Message, user ID. It gets the user. The sender, yeah. We will need the sender because we will need his public key. Oh, and the message itself is coming from the prop, set message, prop message. I'm thinking to message. Yeah, const. I'm gonna add a new decrypted content. Set decrypted content is gonna be use state string. Or I can do initially empty string. Okay, so I'm gonna register a use effect that is gonna do the decryption. Everything here is with use effects. So I'm gonna register a use effect. So whenever our message changes, the message is the message object itself, like that contains the sender, everyone else. So whenever the message, if message is null, we will stop. This is just to ensure that we're not doing anything here. Or even if message.content is null, we're not gonna do anything here. Then here we're gonna do decrypt message.content, and after that set decrypted message, decrypted content to the decrypted message. Now I'm gonna just say decrypted just to see that it works. And here instead of message content, I'm gonna do decrypted content. Decrypted content. Yeah, so going back to our support here, we see the text is decrypted. I mean, it's hard-coded decrypted, but it's there. So now we should think about how we should decrypt it. Decrypt the message. So from app.tsx, I'm gonna grab something from here, shared be decrypt. Message Okay, so box, we can import it. Come on, import doesn't want to import it, but we are gonna do it ourselves. Import box from tweet and knuckle. Pair a public key. This is the public key of the user. So it's going to be user dot public key, where user here we are displaying the user, the owner of the message this user is. Let's also make sure that we have it. Okay, and we also have to, as you remember in our chat room screen, no, where? Message input. Here, to string to convert from a string to a uint array. So let's try to import it from crypto. And pair B, I mean, here is the secret key, but we know only one secret key, like our secret key. So we will decrypt with our secret key, because the message was encrypted with someone else's public key, I mean our public key. And now the same as we did here with our secret key, message. Let's move this logic in crypto. I want to do it there because, yeah, export. It's very technical and you always have to copy paste it. So it's better to put it into an abstract method like get my secret key. And it's gonna do async storage, get item, private key that we will get my secret key. And let's move the private key from here to crypto. Settings, let's copy this from here to crypto. And yeah, get my secret key. And the same thing we will do in the message. Const my key equal get my secret key. It's asynchronous, so let's do let's put this into a function, const decrypt message. Async function that will contain, no, this is outside. It will contain everything that we have here. Let's call the decrypt content. And yeah, get my secret key. Let's import it from crypto. My key. But we can actually do the string to int right away there in the crypto, not to have to do it here. So let's add here const key string equal await Let's add one more closing bracket here and return key string, but with that function string to int. Const declaration require an initialization value. Where is that message? So what's going on there? It's not return null, it's just return. Whew, a lot of things. My key. Undefined is not assignable to parameter. My key. So if my key also return, don't do anything. Okay, decrypt. So shared key is this one. Decrypted is import the decrypt function from crypto using the shared key and the encrypted message, which is message.content. We are decrypting it, and I'm gonna add it here. So async storage get item, that's in crypto. I think we didn't import async storage. Import async storage, save, reload. Crypto unexpected await, unexpected await, because this should be a sync. No. This one. Sorry, async. Reload. Alright. Loading now, but I can check it here. Unable to find more. Reload. Dismiss. Reload. Do something. So run iOS simulator. So something is happening, but the message is not displayed. Let's go in the message input here. Encrypted message. Not in the message input, in the... You moved to Mac again from Windows. No, during live streams, I'm working on two machines. Like my Windows machine is for streaming everything, and my Mac machine is for coding. So I split these two things. Set decrypted. Let's try to console log shared key. And console log decrypted. Decrypt. Okay, let's see what's going on there. So if I go to this group, So what do we have here? Object hello world. This is coming from our app.js. Okay. Now let's remove everything and let's open our support here. It's nothing is happening there, you know. Why decrypt? Oh, I messed up the name of a function. Decrypt message. Can't find variable decrypt. Dismiss. Reload. Okay, come on, let's go. We're almost there. Does companies use Expo or bare React Native? It really depends on the project, not even on the company, because one company can use for one specific project Expo and for one project React Native CLI. So in general, like if your project does not depend on a lot of native dependencies, like I don't know, before there were a lot of libraries that depended on native, but Expo with time added support for them. So for example, right now, even payments with Stripe are integrated in Expo. So a lot of limitations that have been there a couple of years ago are not anymore. But still, like for some application that need that native libraries, in that situation, it's better to go with bare React Native. If you're not sure, you can start with Expo, and at any point you can eject and hope that everything will work okay during the ejecting process. I was trying today to eject a project and I had some issues. I want to talk with the team at Expo to see what's going on there. So, what's happening? What's happening, baby? Come on. Use effect. Console log. Maybe it stops here. Oh, I didn't add user as a dependency to this use effect. So initially the user was not there, the public key was not there, it was ending here, but when the user updated, it did not trigger the use effect to re-render. So right now we have some errors. Can find variable our secret key string. Where is that? Can find variable our secret key string. That's in here. No, crypto. Oh, if key string, then you do that. Yeah. Okay. All right. Okay. Objects are not valid as React Native child found object within key. Oh, right. That means that that everything seems to be good. Here. Decrypted object message hello. So decrypted dot message. Save. Hello. You see? And both of application displays hello. Here you see hello. Let's do it like this. How are you? I'm interested if it will work. What's going on there? Hey, send possible and handled. String split is not a function in string split. String split is undefined string to where is it coming from? Message input string dot split split. No, it should be in crypto. String str. I don't think it's string dot split, or I don't know. Message input I don't need here async storage. I don't need here what else? Stat. And that's it. Our secret key string. And here I do not need, here I do not need to convert it. If our secret, if it's, then we will return. Okay, okay. Now let's try to send one more. Hey. Again unhandled. Content split is not a function. In content split is undefined. User public key. Where? Wait a second. And here as well. Yeah. Oh my god. And it's not a string, it's our secret key. Okay. Okay, okay, it works. It works. And from here, how are you? Send. How are you? Boom! It's done. It's done, guys. And I'm not sure if you realize like the whole concept of this, because it looks like it was working beforehand, but yeah, you can see here on the phone as well the messages are decrypted. Come on, how are you, and hello and hey, and you might think, okay, and it was the same before, but now we are as the application developers and as the application admins. If I go to the content right now, if I go here to the content and check for the messages, the one that has for user, like these messages. For example, this one. This is the content. You don't know what is written there, and there is no way you, as a developer and anyone else, to decrypt this message without knowing the private key. But the private key is kept only on the user device. It never leaves the device unless, I don't know, the device itself is hacked. And in that moment, you can regenerate and create a new private key. So Yeah, even knowing the users, for even knowing the users public key that we save in database, with this public key, you cannot decrypt any messages. With a public key, we only encrypt it. And we use the private key that we never share to decrypt the messages. And these messages are separate and individual for each user. The message, hey, how are you here, is not the same as, hey, how are you here. There are different messages in our database, encrypted with different keys. And when you decrypt it, you get the same content, basically. So, yeah, that was everything that was planned for today. Like this build is, to be honest, mind-blowing how in depth we went with this build. We, like, especially with this end-to-end encryption, we implemented this asynchronous encryption. It's something that you cannot find probably anywhere on YouTube. So if you enjoyed this video, guys, smash the subscribe button. And also, let me know if you would like to see this feature. If you'd like me to create a shorter video that will explain implementing this end-to-end encryption. Because what I'm thinking right now is that this concept is very powerful, and there is not enough resources on the internet that will teach you how to implement this end-to-end encryption. So I'm thinking that at the moment this content on the channel is buried under the 6th video of a signal clone. So not everyone will be able to follow all 6 videos to get to this point. So I'm thinking maybe to create this end-to-end encryption in a small video of 1 hour or 1.5 hours, where we will implement it in a very simple basic application that will focus only on this end-to-end encryption. Are you going for number 7? Yeah, like if you have any questions right now, guys, let's spend some time answering questions, and then we can get started with our weekend. Are you okay, James? In 20 minutes, I've got 2 automated emails from your courses, no reply email. That's weird. Can you please send me more details, because I'm not sure if I understand it correctly. But if it's a problem with a course platform, please let me know. Send me an email at Vadim at notjust.dev. And yeah, because this is very important, I'm gonna try to fix it. Are you going for the number 7? For the same reason as I said before, like too long, the builds that take too long, like 7 videos, 8 videos, and so on, they're not very effective because most of the people already dropped out of implementing this build. So I reserve this very long, very in-depth tutorial for the course, for the premium users that are joining my course that I'm working right now. And there I know that people have paid money and they are dedicated to learn and to go through all of these features. But, and yeah, like there I'm going very in depth. But yeah, like this signal, I'm impressed of how many features we implemented. As a homework for you guys, try to not only encrypt messages, but also encrypt images. Let me think if that's much more complicated than this. It might be interesting how you will transform an image to a buffer of bytes and if you do that, then you call the same encryption and decryption methods that we used today. All right. Implementing reactions to messages would be really cool. I'm gonna think about how to integrate this feature in other smaller projects or videos. Okay. Nadal, regarding a roadmap for React Native developers, yeah, you can check a lot of project tutorials on my channel. I recommend everyone to start with a Tesla clone because that's a very easy clone, and under 2 hours you build a Tesla clone. And after that, once you get your hands dirty with React Native, then you can get into these more advanced tutorials that we have here. Congrats. Thank you very much. I really appreciate it. Okay. Good question. In case the device is hacked, the attacker can read all the previous messages. Short answer, yes. In case the device is hacked, the hacker will be able to get the private key, and with that private key, he can decrypt all the messages that user received, but only those messages. He cannot decrypt the messages that the user sent. He cannot decrypt the messages from another chat room. He can decrypt only the messages that was received by that user. So yeah, the only vulnerability for this asynchronous encryption is if your device is physically hacked. Like, I mean, if they get access to that private key. And that can happen if your device is hacked and they get the private key. But in that case, they also need to know the password for the application to be able to log into your account. So you can implement more steps of authentication like MFA to protect your application with MFA, like multi-factor authentication. And in that case, again, it's going to be, they should get both your password, your MFA security, and also your private key that lives on your device. And another vulnerability is, let me show you where. It exists, just know that it exists. Most of application should not worry about this. Like big application like WhatsApp and Signal, they probably have something in place for this. So where I can draw something. So let me open that. How is it called? So the only vulnerability is this link, like this link. Save public key to database. Because you are sending this through the network, there might be a man in the middle, like a hacker. How do you draw a hacker? Like this, with a hat. Sorry for my drawing skills. That can intercept your connections, especially if you are not using a secure connection like HTTPS or if you're using HTTP. Then they can intercept your connection and do like get your private key, your public. Wait a second. I'm talking, but I don't know what I'm talking about. This is the public key. Wait, no. I confused with something else. Even if they get the public key, they do not know the private key and they cannot decrypt your messages. Let me remember. I think there was a vulnerability like this with a man in the middle. But yeah, no. This is not the case in this asynchronous situation. So the only way to hack it is to get access to this private key, which never leaves your device, is not sent through the network, is not saved in the database. It's only you who have it on your device. Okay, and I just realized I was not sharing the screen. Oh, what I was drawing here is this private key being the only vulnerability, which is saved on your device. All right, okay, so welcome to the notjust development community. Hello. Okay, guys, so if you don't have any other questions, I'm gonna have to go. I still have to work a lot for the course, and also the weekend is coming, and yeah, still have to do some work. So thank you very much for being with me until the end. It has been the 6th video of the signal clone, and in this video we have implemented end-to-end encryption. Where is it? End-to-end encryption with asymmetric key pairs, with a public key and a private key, and yeah, it was something. I'm pretty happy with the build that we are finishing with, and now I can sleep tightly without thinking that I promised encryption but I didn't deliver. Now it's here, I delivered it. So what else, guys? Yeah, let me know down in the comment what other builds and what other tutorials you would like me to do next. And until then, keep grinding, keep coding, and I'll see you next week. We are preparing some new videos, which are not going to be only live streams. So make sure to turn on the notification bell, not to miss them out. One of them is authentication. So building custom screens with React Native and AWS Amplify is coming. So stay tuned, and let's roll the outro. And as always, guys, take care, stay hydrated, and write clean code. And now I